This is our second example on slope fields. And you're just going to do the same thing. The first step is equate dy over dx, um, which is y minus 2x. Equate that to m. So we can say equate this to m, but we know this is equal to y minus x. All right. Now, what you're going to do next is to start with isoclines. All right. So we need to draw this isocline so that we can be able to easily get the slope field. Now, let's start at m is equals to -3. Y will be equal to x minus 3. At m is equals to -2, y will be equal to, and I'm just using this, you know, this equation here. Plug in m, find the function that you're going to plot. Now, for the that will represent the isocline for corresponding values of m. So at m is equals to -2, y will be equal to x minus 2. At m is equal to -1, y will be equal to x minus 1. At m is equal to 0, y will be equal to x. At m is equal to 1, y will be equal to x plus 1. At m is equal to 2, y will be equal to, and I may have to just scroll down. X plus 2. At m is equal to 3, y will be equal to x plus 3. Now, all these guys here, right, are what we call isoclines, all right? All these guys, all right? These are what we call isoclines. Um, now that we have them, we can go to our diagram and try to draw these guys. And hopefully they'll give us a good slope field that we can plot functions on it, generate family of functions. So I'm going to start with the first one. Y is equals to x plus 3. So y is equals to x plus 3. Oops, is that a line? Not really. Okay, need a line. And hopefully that color, that. So, all right. So, should pass through there. Okay. I need another one again. Okay. All right. I just need to. All right. Another one that passes through this point. All the way. Another one that passes through this point. It's a tedious process, as you can see. But this is how you approach these questions. So y x plus 3, x plus 2, x plus 1, x minus 1, minus 2, and minus 3. Okay. Another one. So these are what we call isoclines, and they will just help us to draw the slope field. Okay. Now that I have them, I'm going to indicate the slope field of each isocline. Now, remember, for the y is equals to x plus 3, m is 3. So here, m is equals to 3. Here, m is equals to 2. M is equals to 2. M is equals to 1. M is equals to 0. M is equals to negative 1. M is equals to negative 2, and M is equals to negative 3. So those are the corresponding values of the gradients of each of this. Actually, let's start with the easy one. We can start with the first one at the top. So the gradients of y is equals to x plus 3 at any point is 3. So make it quite steep. Oops. Something like that. So, and then the next one is 2, so less steeper than that. Hopefully. And then 1. And then 0. So at any point on this curve, the gradient is 0. Any line that crosses this curve at any point, its gradient should be 0. And then negative 1. And then negative 2. And then negative 3, which is much more steeper. Okay, so something like that. Now, suppose we want to, remember, for example, when a curve crosses this line, all right, let me use this example here. This one here. When, I think this is important, when a curve, so what I'm trying to write here is when a curve crosses this line, its slope must be equal to 0. Its gradient must be equal to 0. So when a curve crosses this line, its slope must be not 0 but negative 3 must be equal to negative 3. So its slope must be equal to negative 3. All right. Okay. So what you're going to do now is to sketch those. Let me put that in a bubble. All right. So what you're going to do is to try and sketch a family of functions here. See what we have. So let's start with one possible. All right. So this one is one possible function that you can have. So the gradient at this point is 0, negative 1, and then goes like that. So that's one possible function that you can have. Another possible function that you can have is this one. You can also have this one. Okay, that one. And you can see that at this point, the gradient of the function is 0. This point, the gradient of the function is negative 1. This point, it's negative 2, negative 3. Very important. Okay. Another possible function that you can get from this is this one here.